Good day, student. Welcome back, grade 8. My name is Mrs. Longo CK. So today I'm going to teach you about energy in transfer system, which is under a topic of energy and change. What we need to understand after this lesson is to able to identify part of a simpler circuit, draw and interpret circuit diagram, understand open and closed circuit, know the function of each component. So we have to define what is electrical circuit. Firstly, we have the simple circuit. In a simple circuit, we have a battery, a wire, a switch, and a light bulb. What is a circuit? An electrical circuit does it allows the current to flow from one object to another. So the current will be flowing where? Here. The electrical charger will be flowing here, around here. So let's go deeper to the definition. Electrical circuit conduct paths for electrical charge to move from one object to another. When designing a circuit, you can also draw a diagram using symbols. So meaning that when we draw a circuit, we can represent it by symbols. A battery has a symbol, a switch has a symbol, a wire has a different what type of symbol. So when we are drawing a circuit, we can represent it by a symbol. Electrical circuit is a circuit is a path that allows electricity to flow. It includes a power source, wire component like bulb, component of a simpler circuit, a cell or a battery, a source of energy, a wire, it carries electrical current. A bulb is an output device, and a switch, it controls current flow. Electrical current. This definition is important because we had in an electrical circuit, it travels from one object to another. Electrical current is a measure of flow of charges around the circuit. It's measured in what? In ampere. So in our general everyday life, what we need to understand about the electrical current is that it's like water in a pipe. We have a water in the bathroom, we have a water in the kitchen. So the same way with what electrical current, it flow from like a wire. Water flow from the pipe from one room to another. Whereas the electrical current flow from one object to another. Think of it like a water flowing through the pipe, but instead of a water, it is a tiny charge particles moving from a power source like a battery through the wire and a device like a light bulb, then back to the source. A potential difference. A potential difference is a push or a force. It helps the traveling of what of an electrical current in a what in a circuit. So let's define potential difference or a voltage. It's the push that makes electrical charger flow in a circuit, like a pressure in a water pipe. It represents the energy transfer per unit of a charger, measured in volts. In a simple analogy, it's the water in a slide. The difference of the height between the top of a slide is like the potential difference. The greater the height, the faster the water flow. Just the large voltage makes the charger flow faster. Yeah, let's go back to the definition. The voltage is a force. When we force something, we push something. The more we apply more force, it's more when that thing it will flow. The same way here they are saying the water in the slide. The higher the height, the water will flow faster. The same way with what electrical current. When the voltage is higher, which is the push, it will flow faster. And we have the term resistance. The term resistance is come from the word resist. Resist. The word resist is to refuse to accept, it's the opposition. You don't allow. So resistance is a general term for opposition to a force or an inability to accept something new or different. But in a physics viewpoint, resistance specially refers to the opposition to the flow of current or the flow of heat, as is seen as an ability to conduct to limit passenger of the electron. In general sense, refusal to comply. It means refusing to accept or participate in something like a person resistant to a new policy or a group of resistance against in an invading what force. Opposition to change is the act of opposing or withstand something, whether it's physical or new idea. And we have electrical component. An electrical component is a general term for any part of an electrical circuit. This include, but not it is not limited. It includes wires, switches, and resistors, but they are not limited. We have our voltmeter, ammeter. An electronic symbol is a pictogram used to represent various electrical and electronic devices or functions, such as wires and batteries, resistance, and then transistor. Here are the symbols. We have symbols to represent the circuit. So we have symbols and function. We have a cell. This is the symbol of a cell. Provide electrical energy, a power supply, and a symbol alternative to using cells. A wire, a symbol, it allows current to travel. A bulb, it converts electrical energy into a heat and light energy. And we have a switch which controls what allows circuit to be open and closed, and it controls the flow of electrical current. And this is the simpler circuit, which is represented by what? By symbols. In that other slide, we had what? A real life symbol circuit, but this one is represented by what? By symbols. So when I say go and write, go and draw the symbol circuit, you have to go and draw using the symbol. Type of a circuit. We have an open and a closed circuit. In these two circuits, we have two examples. Let's first define a closed circuit. Electricity can flow, and open circuit, and electricity cannot flow. Like I said, this is the open. You see, it's not closed, and the electricity cannot what flow. And this is what the closed one, and the electricity can flow. You can see these arrows, and the electricity can flow. Effect of electrical current. We have four different types of heating effects. Of effect that plays a role in electrical current. We have a heating effect, lighting effect, magnetic effect, chemical effect. And let's go and see what this effect help us in an electrical current. Heating effect. When a current flows through a resistor, it produces heat. So when a current flows from a resistor, it produces heat, and we have different of things that we use at home. We can see with this one, follow after what a heating effect, and which is an ion, electrical heater, kettle, and a hair dryer, which produces what? A heat. And lighting effect. When a current passes through a filament, it glows, just like a lamp and a bulb, and what? A magnetic effect. An electrical current create magnetic field, e.g. example electronic, magnetic, and electrical motor. Chemical effect. Electrical current can causes chemical changes, example electroplating and changing battery. We have the safety, secure safety. What we need to know to be safe when we are dealing with circuit: never touch the wire with a hand and use the fuse or a circuit break. Do not overload the plugs. Don't put a lot of plugs. And energy efficiency: not all energy is useful. Some energy is lost as what? As heat. Efficient system waste less energy. And we have a summary of this topic. What we need to know: electricity transfer and changes energy. Energy can change from chemical to electrical, light or heat. A circuit must be closed for what? A current to flow. In real life application: electrical stove heat energy. TVs is light and sound. A fan is a motion energy. Yes, in an electrical circuit we have what energy? Heat energy. And a TV light energy. So this is a class activity that you are going to complete before our next lesson. Go and complete: draw a closed and an open circuit, define electrical circuit, and draw a simple circuit in symbols. Draw a simple what? Circuit in symbols. Thank you.